Dear friends, now let's look at an example using Staad, one of the popular analysis programs we've actively integrated with. The process for other supported finite element software is analogous. Data extraction. We use a small plugin, a console application using the Staad API, that extracts all the necessary data as is directly from your calculated Staad model. You don't need to manually create any tables within Staad. To export the model, you need a calculated Staad model with design sections. Our data extraction plugin compatible with your Staad version. Generated files. Before running the extraction, simply select all the elements in Staad that you want to see on our portal. After that, you need to run our plugin and wait for the data extraction process to complete. The resulting CSV files containing the project's database will automatically appear in your project folder. For Staad, the export typically includes 7 CSV files, such as 1. BEAM, general information about elements, including analytical element ID, start node, end node, profile name, material, and length. 2. Beta angle, information about the rotation angle of elements. 3. Forces, connection forces, 6 components, F, X, Fy, Fz, Mx, My, Mz, at the ends of each element, for the relevant load cases or combinations. 4. Node. Node information, including node number and coordinates, x, y, z. 5. Property section. Section property parameters, geometric characteristics. 6. Release. Information about end releases, pinned, fixed, sliding. 7. Settings, units and settings used in the specific Staad model. And 2 important things. First, in our portal we use parametric profiles. A key point here is that profiles are stored parametrically, using their geometric properties. This avoids the common problem of needing manual mapping files to match profile names between different software, which can vary significantly. Second, all these generated CSV files are then automatically uploaded to our portal. The platform processes them, converting the data into our unified database format. It intelligently handles differences in coordinate systems and force sign conventions between Staad and our standard, significantly simplifying subsequent analysis and design steps.